Hello, everyone, and welcome back. I hope you are safe and well wherever you are, and you've found a place where you can stay for the next 7, 8, 9 weeks. I don't know how long it will be, but I am sharing with you the first sort of content video here. If you haven't already watched the welcome video that explains some of our procedures for the next half of the semester, please watch that first, and then you can launch into this one. So just to recap where we are now embarking into aquatic ecosystems. We, before break, took a little look at forest ecosystems and grasslands, and then a very, very quick look at dry land ecosystems, thanks to Casey mostly. And now we're going to do some aquatic ecosystems. So we'll do streams and lakes and wetlands over the next several weeks. Excuse me. But you'll see a lot of the same themes that we talked about in the first 5 or 6 weeks of theory that we applied to terrestrial ecosystems. You'll see the same things pop up in aquatic ecosystems, although they're a little bit different. So today I just want to kind of give you a brief introduction to some terms of stream ecology, and then I will point you to some readings that you can do to get up to speed on this. So stream ecology, even though we're talking about rivers and streams and creeks, they're all called streams. So this is stream ecology. And there are a lot of different terms that it would be good for you to know so that we are using the same language. And you'll see these in the readings as well. So here's a good place to start. Here's a picture of what's called a riparian corridor. So that word riparian there means alongside a river. So here is an upland area that is alongside a river, so it's called a riparian area. These are actually considered wetlands, even though they're not wet all the time because they flood occasionally. And in some parts of the world, they're flooded enough that they are considered wetlands. Here's the actual stream channel itself, the stream bed and the channel that is flooded. And we have a couple of terms to go with this. So here's a nice little diagram that shows you some of the important terms. There's the stream channel, the bed itself. Here's the riparian corridor along either side of the stream. And then we have these areas that you might think if you were riding a canoe or paddling a canoe down this stream, the kind of gravel bed or sandbar along the side, that's called the parafluvial zone. That means alongside the channel of flow, parafluvial. And of course, that's a really interesting area for a lot of things to live. Then we have the area beneath the stream, an area that you don't usually see. That's called the hyporheic zone. It means below the flow. So you can see some arrows here. There's exchange of water and organisms and material from the water channel itself to the parafluvial zone, to the riparian corridor, and even this way vertically with the hyporheic zone. So there's groundwater down here that gets exchanged with the surface water back and forth. And there are organisms that go back and forth too. So these are all important terms. So when we talk about streams, we're not really just talking about the surface water that you can see. We're talking about the below ground water, we're talking about the parafluvial zone, we're talking about the riparian corridor that might only be flooded a few days out of the year. Right now, we got a ton of rain here last night, and our riparian corridors are flooded in Granville. You're missing that. I know, it's very exciting. So let's talk about some stream ecosystem axes. So this is the way energy and water might flow. This is called the longitudinal axis. Along the channel of the stream. This is called the lateral axis. So as water exchanges with the parafluvial zone and the riparian corridor, that's a lateral exchange. And then we have this vertical arrow here, so vertical exchange with the groundwater beneath. So longitudinal, lateral, and vertical exchange. Those will become more important as we move on. Another thing that's good for you to know that often stream ecologists talk about is stream order. So we have a system of naming streams with numbers. The very smallest streams that you could probably jump across with one big step, those are called first order streams. When a first order stream joins another first order stream, now it's called a second order stream. So to jump to the next level, you have to join a stream that's at least your own size. So here a second order stream is joining another second order stream, and we get a third order stream. A third joining a one, it still remains a third. You have to join another third or way over here to get to be a fourth order stream. So if you're talking about a first, second, maybe third order stream, those are pretty small. Like I said, you could jump across a first order stream And a second and third order stream you could wade through, maybe just get your shoes wet. If you're talking about a fourth, fifth, sixth order stream, those are larger. You could probably canoe in those pretty easily or kayak in them. If you're talking about a seventh, eighth, ninth order stream, now you're getting to some of the largest rivers in the world. So the mouth of the Mississippi or the Amazon might be a ninth, 10th, 11th order stream. That's about as big as they get, really. So these numbering systems sort of helps let us know what size of stream you're talking about and what kind of watershed has fed into it. A few more terms. So in the landscape, we talk about the headwater streams, which are usually coming off a hillside or a mountain. We don't really have mountains around here, but we have some hills. So water coming off an upland area might be called a headwater. This zone is called a transfer zone as water exchanges with the floodplain. And then we have this depositional zone where a lot of that eroded material and detritus from these upper zones gets dumped in the delta here, or gets dumped out in the bay in this case, or sometimes even dumped out in the floodplain as the river floods and then exchanges sediment and material. So headwater zone, transfer zone, depositional zone. A lot of terms today, sorry. Almost done with terms, and then we'll get into some concepts of models of streams. Maybe if you spent much time with streams, you're familiar with some of these terms before. So this is looking at a stream in cross section, and this is called a plan view here. So we have areas where water is moving rapidly and kind of bubbling over, tumbling over rocks and things like that. We call that a riffle, fast moving area. Sometimes we get like mini waterfalls that are called races. And then kind of longer, fast flowing but shallow areas that are called runs or glides. Here's a glide, here's another glide. And then occasional slower flowing deeper areas that are called pools. So here's a pool on this, and here's a pool in this view. So roughly we're talking about riffles and then runs or glides and pools. These are different habitats even within a stream where different kinds of critters can live. Okay, so we're going to spend today and the next lecture, the next video lecture, and some of your reading looking at some different sorts of ecosystem concepts that have sort of evolved over the last 100 years or so. Early on, a lot of people sort of classified rivers based on what kind of fish live there, and mostly about fish body form. So this little picture kind of shows you this fish zone concept. It's not really used much anymore, but in low order streams, so headwater streams, you got a lot of this sort of body shape, which is kind of this spindle shaped, long, you could think like a trout body shape, long, slender, muscular, able to swim in very fast flowing current very easily. Those tend to be in very fast flowing, low order type streams. Let me go back. A middle order stream would have sort of an intermediate body shape, and then a larger order stream where the water is sort of slow moving, you get a fish body shape that almost looks like what you would find in a lake. So something like a sunfish type shape, or maybe a crappie type shape, almost looks like a pan. So just the body shape of a lot of fish sort of changes as you go from those low order streams to high order streams. So that's the fish zone concept. We won't spend much more time talking about that. It's the middle three and kind of the fourth one that we're going to spend some more time on. The second one is really important, and I'll spend a few minutes on it. It's called the river continuum concept. It's kind of a famous ecological concept in stream ecology, and it is all about the longitudinal flow of material and organisms through the stream. So let's take a look at that. Here's a famous picture. It's got a lot of details, so you might want to spend some time with it. It's put together by researchers led by Van Oot et al. In 1980, put together this river continuum concept. And it was mostly based on rivers in North America and Europe, not in the tropical zone, but in the temperate zone. So a bunch of things going on here. You see the stream order here. So stream order 1, 2, 3, these are fairly small streams. 4, 5, 6, medium-sized rivers, and then 7, 8, 9, 10, biggest rivers in the world. So they show this all in one diagram from tiny to large, but of course rivers don't really work that way. They're just trying to show it that way on this diagram. What they're trying to show here is that in small order streams, you get a lot of